And in case, and you can see, this is the incident wave and the refracted electromagnetic wave goes in such a way. When we use metamaterial, this kind of suggested by Professor David Smith. And again, we have incident wave, reflected wave, and refracted. And refracted is in this direction. In this direction. And you can please pay your attention. The arrow for this wave is shown in such a way, and in metamaterials, in the opposite direction. The electromagnetic wave, the phase velocity is directed opposite, in opposite direction. And it was experimentally shown that if this is the angle from the normal. This is the normal to the boundary. This line is the normal perpendicular to the boundary. Again, here we have the normal, and here is the positive angle, and for this case, it is negative. And you can see, this picture was obtained for Teflon. This is non-direct material. It is shown here. You can see the 30 degree is the angle of refraction, this angle. And for left-handed material, which is composed of this artificial structure, it was demonstrated that the angle is negative, minus 60 degrees. It was experimentally obtained. This is results of simulation, of modeling. If you have this incident angle, incident electromagnetic wave, then it goes inside this metamaterial, and this is direction of refracted electromagnetic wave for normal material, and this is for metamaterial. So the first property, first characteristic feature is negative refraction. If we use metamaterial, this artificial structure, then we can observe the negative refraction. And now, it is very important. Material classification from the point of view of existing metamaterials, negative or left-handed material. I will use this board, left-handed material, or metamaterial. What we have here. So, this is the axis of dielectric difference, and the vertical one corresponds to mu, magnetic permeability. Here we have both parameters are positive. Positive and positive, epsilon and mu. This is a normal material with forward wave propagation. That is important. Forward wave propagation. We have the forward electromagnetic wave. That means that the pointing vector and of course phase velocity have the same direction. You can see this is the propagation of the electromagnetic wave from the source to somewhere. Another case, metamaterial. Metamaterial. Both parameters are negative. Both are negative. You can see it was named Veselagos materials, because Veselaga was the first scientist who proclaimed that these electromagnetic waves can exist in such a medium. What we have here, left-handed materials. These materials, normal materials, are right-handed. And here we have left-handed. Правый и левый. правосторонний, левосторонний. Left-handed and backward wave propagation. The wave propagates in another direction, in the opposite direction. Is it possible to observe such a combination? For example, dielectric permittivity here is negative, dielectric permittivity is negative, and magnetic permittivity is positive. These materials are known as single negative material. Single negative. Only one parameter is negative. In this case, the wave doesn't propagate at all. It attenuates. It is impossible to observe propagation of the wave, and it is known as evanescent wave. The wave attenuates and doesn't propagate. The same in case of only mu is negative and epsilon is positive. Again, we have single negative structure or single negative material. Again, there is no propagation. The electromagnetic wave is evanescent. It can be observed in normal materials, very narrow frequency range, for example, for ferrites. The same may be observed for ferroelectrics in very narrow frequency range. So we have four kinds of materials. This is double positive material. Double positive. Both are positive. Double negative material. This is negative. Single negative with dielectric permittivity negative. And again single positive, but only mu is mu.
Provision of magnetic waves, electromagnetic waves, or just electric waves?
Electromagnetic. In any case, electromagnetic. Only both components exist in electromagnetic wave. There is no electric wave or magnetic wave. But only in case of specific materials, for example, spin waves. But we not say about specific waves, only electromagnetic waves. And in any case, presents electric component and magnetic components, both. But the parameters may be different by sign. Both positive, both negative, or single negative. So this is very important thing, this classification. And why the refractive index is negative? Let us discuss this problem. This is a normal material which consists from atoms or molecules. They are situated in some way. This is very often is regular structure, maybe not regular structure, nevertheless. These atoms are situated in the structure, and the material is composed from different atoms. And for these materials, we can observe positive parameters. And the refractive index is defined by this relation. And is refractive index. It depends on these two parameters. Epsilon only, nothing more. Square root from this product of epsilon and for normal material it's positive. Of course, you can say that we can choose a sign before the square root, plus or minus. We say it was chosen that for normal material, we say we use the sign plus for this case. And don't consider minus. Because as I have shown, the energy transfer and propagation of the electromagnetic wave are in the same direction. So we say that the diffraction index is positive in this case. But this is artificial structure, metamaterial. It may be engineered in such a way or in such a way. It may be dielectrics, in this case, again, dielectrics. And this regular structure containing a lot of these artificial atoms, we consider each component as an artificial atom. They form the regular structure, and if the condition about the wavelength and dimension of structures is fulfilled, see again, the condition related to the ratio of dimensions of wavelength and dimensions of structure. If all dimensions, distance between components, and in this case diameter of this component are less than the wavelength, much less, then it can be considered as a structure which is similar to normal material. And we can use effective parameters, effective dielectric permittivity, effective magnetic permeability. And in this case, these parameters, effective parameters, are negative. Why? This diffraction index is also negative. I will show you how we can explain. If epsilon is negative and mu is negative, then we can present this parameter by amplitude and phase of this value. In general case, this parameter is complex, which has real part and imaginary part. In case of lossless structure, lossless without losses, без потерь, lossless, без потерь. If this the structure of medium is lossless, then we can present by this. This is a real part, and this is the part which depends on this phase. This is the phase, and this is imaginary unit. So for both materials, we can present in such a way. Then n, diffraction index, n squared, is defined by this product of these two parameters. And if you substitute these parameters, we obtain this expression. How this phase depends on the sign of epsilon, positive, plus or minus. For plus, this phase is equal to 0. And we have only epsilon sub r, mu sub r. But if they are negative, then the phase is equal to pi. Do you remember this transformation? If it shows this pi is equal to pi, then we have cosine plus r this is equal to 0. And this is equal to -1. Okay? So, if this phase parameter is equal to pi, then it is equal to -1. So this side, this negative side, we have obtained introducing this phase parameter. Now, in order to find the fractions index, we have to use this square root from this equation, and the phase component looks as is shown here because this is square root. This is pi and this is pi, so we have here the phase parameter which is equal to pi. This is -1, so this is a negative diffraction index. And the refracted electromagnetic wave goes in such a way as I have already shown, which was obtained by Professor Smith. Now, so let us stop and make a break for 5 minutes. Let us ask Russian, if necessary, 5 minutes only, and then we continue.